Good morning, students. In previous class, we discussed example 12, that is simply supported beam with UDL. This is the problem which is discussed in the previous class. UDL with simply supported with 2 points loads on UDL, and we found that the deflection at a different point, that is C, D, E. And in this class, this is the problem which we are going to discuss. It is also simply supported beam with some 40 kilonewtons acting on a 40 kilonewtons acting on a anchor which is located at point D, that is L section. So determine the deflection at point C and D. What is the deflection at point C? It is under the 90 kilonewtons, and at point D of the beam as shown in figure. The flexural rigidity of the beam is 90,000 kilonewton meter square. So a total beam load మనం find చేయాల్సింది deflection at point C and D. So this is a given diagram, and you should modify this diagram. This is the modified diagram. When the 40 kilonewtons any load acting on an angle or L section which is located on the beam, due to this 40 kilonewtons, a direct load is acting at point D, and also due to 40 kilonewtons which is acting at 1 meters from point D. Due to this eccentricity, a couple is acting at point D. A movement will be developed at point D, that is 40 into 1. 40 is the load which is acting at a distance of 1 meter from point D. Therefore, moment will be developed at point D is 40 into 1, force into perpendicular distance. So 40 into 1 is the 40 kilonewton meter, which is moment will be developed due to this 40 kilonewtons, and also a direct load acting at point D due to this 40 kilonewtons. So this is the modified diagram. 90 kilonewtons at point C and 40 kilonewtons a direct load acting at point D. Along with this direct load, a moment will be developed at point D, that is 40 kilonewton meter, 40 into 1. Okay. Total length of the beam is 6 meters. Total span of the beam is 6 meters. 90 kilonewtons is acting at a distance of 1 meter from the left support, and this is 40 kilonewtons, and 40 kilonewton meter will be developed at a distance of 4 meters from the left support. Okay. So before proceeding to the problem, we should find the RA and RB, reaction forces at A and B. So take the XX section at a distance of X. The XX section must be covered all the loads which are acting on the beam, and which is at a distance of X from the left support. Okay. So find the RA and RB. To find the reactions RA and RB, by taking the equilibrium equation sigma Fy equal to 0. So RA plus RB, that is upward forces, must be equal to the downward forces. What are the downward forces here? 90 kilonewtons is there and 40 kilonewtons is there. This is not the load, which is a movement which you should not take as a force. So upward forces are RA, RB, and downward forces are 90, 40. So 90, 40, 130. RA plus RB is equal to 130. And take the moment at point A, another equilibrium equation, sigma MA equal to 0. By taking the moment at point A, if we take the moment at point A, this is RB is the force, and the distance is 6 meters. RB into 6 meters in anti-clockwise direction about point A. So RB into 6 minus this 40 kilonewton meter is in clockwise direction. Therefore, minus 40 kilonewton meter. You should not multiply with the distance with this couple. Only you should take a simply 40 kilonewton meter. So RB into 6 minus 40, and also minus 40 into 4 meters. This 40 kilonewtons direct load is there. 40 kilonewtons into perpendicular distance is 4 meters from point D to A. So minus 40 into 4 minus 90 into 1, because 90 kilonewtons developed a clockwise movement about point here. That's why I'm taking 9 minus. That is equal to 0. So RB into 6 minus 40 into 4 minus 40 minus 90 into 1 equal to 0. This minus 40 is the moment. This minus 40 is the load. So RB into 6 is equal to 290. After calculating these things, 290. Therefore, RB is equal to 290 by 6, 48.33 kilonewtons, and RA. If you substitute this RB value into this equation, RA plus RB equal to 130, then we can get the RA value as 81.67 kilonewtons. So these are the reactive forces at supports. After finding the reactive at supports, consider a section XX at a distance of X from the left support. After considering the section XX, find the bending moment at XX. What is the bending moment at XX? This is the bending moment. Bending moment. How to find the bending moment at XX? The bending moment at XX means the moment developed by all the forces on the right hand side. Moments developed by all the forces on the right hand side of the XX section. So on the right hand side of the XX section, the forces are RB, 40 and 90. And also along these three loads, along these three forces, another moment is also there. So whenever you calculating the bending moment, you should consider the 40 kilonewton meter. Now bending moment at XX is equal to RB into how much distance? RB into this much distance. How much this distance? Total distance is RB into this is the 2 plus 3 plus 1, 6 meters. So from 6 meters subtract the X distance, then we can get the distance from XX to B. So RB into how much? 6 minus X. Then this 40 into how much distance? This distance how much? So from point D to A is 4 meters. So from point D to XX section is 4 minus X. So 40 into 4 minus X. And also minus 40 is also there. And 90 kilonewtons is there. How much distance, perpendicular distance between C and XX section? From C to A is 1 meter. So 1 meter minus X. So 90 into 1 minus X. This is the bending moment equation. So write the bending moment equation like this. So this bending moment is RB into 6 minus 6. RB value is 48.33, which is positive, anti-clockwise. Minus 40 into 4 minus 6, which is the load acting on the beam at point D. Minus 40. 40 is the couple developed or moment developed at point D. You should not multiply the distance with this couple. Only simply have to write the couple, which if it is clockwise minus, if it is anti-clockwise, which is positive. So here the couple is developing at the point D is in clockwise, therefore I am taking the minus. Minus 90 into 1 minus X. This is the bending moment at XX equation. Then from the curvature equation, EI d square y by dx square is equal to minus m is there, curvature equation it is. So in this curvature equation, substitute this m value, m equation at this place. So EI d square y by dx is equal to minus m is there. So here in this equation, the sign conventions are reversed. So minus 48.33 into 6 minus x plus 40 into x 4 minus x plus 40 plus 90 into 1 minus x. This is the curvature equation after substituting the bending equation. Then by solving this equation, we will get the slope and deflection equation. As earlier I said, from starting onwards. How to integrate? Integrate by the Michaelis, according to the Michaelis method. So according to the Michaelis method, if we integrate, the left hand side is EI dy by dx is equal to, if we integrate this term, 6 minus x is assumed as a whole bracket term is as single term. So while integration of 6 minus x, we will get the 6 minus x whole square by 2 minus 6 minus x whole square by 2. So minus positive, 48.33 into 6 minus x whole square by 2. Next, integration of 4 minus x according to the Michaelis method is minus 4 minus x whole square by 2. So 40 by 2 is 20, minus 20 into 4 minus x whole square. Plus 40 is the constant value, integration of 40 is 40x. Next, 1 minus x integration is minus 1 minus x whole square by 2. So by 2, 90 by 2 is 45, minus 45 into 1 minus x whole square, plus C1. This is the integration according to the Michaelis. C1 is the integration constant. Then integrate once again. If we integrate this equation once again, we will get the deflection equation. So left hand side is EI y. It becomes EI y. EI is the constant and the integration of dy by dx is y minus. Here 6 minus x whole square by 2 is there. Integration of 6 minus x whole square by 2 is minus 6 minus x whole cube by 6. So minus 48.33 already is there. 6 minus x whole cube by 6. Whole cube by 3, actually 3 into 2 is 6. Integration of 4 minus x whole square is minus 4 minus x whole cube by 3. So minus plus 24 minus x whole cube by 3. Integration of 40x is 40x square by 2. So 40 by 2 is 20x square. 1 minus x whole square integration minus 1 minus x whole cube by 3. So minus plus 45 1 minus x whole cube by 3 plus C1x plus C2. C2 is the second integration constant. C1x is C1 is the constant. Integration of constant is C1x. These are the two equations represent slope and deflection equations with C1, C2 or constants. So by replacing C1, C2 with values, if you get the C1, C2 values, if you want to get the C1, C2 values, we should substitute a boundary conditions. What are the boundary conditions for the simply supported beam? For this simply supported beam, deflections. Once again, look at this diagram, modifier diagram. After applying the load, the beam bends like this. Beam deflects like this. So after deflection of the beam, the position of the A and position of the B doesn't change, which will not change at point A and B, and that means deflection at point A and deflection at point B is 0. So see, at x is equal to 0, that means at left support, deflection is 0, y 0, and also at x is equal to 6 meters. If x becomes 6 meters, right support is also deflection is 0, y 0. So x is equal to 6 meters, y 0. These are the two boundary conditions for this given problem. So these are the two boundary conditions. At x is equal to 0, deflection y 0. At x is equal to 6 meters, also y 0. So by substituting these two boundary conditions into our slope and deflection equation, we will get C1, C2 values. So from the boundary condition 1, how to substitute the boundary condition 1? The boundary condition 1 represents the deflection 0 at x is equal to 0. So in deflection equation, we should substitute the boundary condition 1. So deflection means y. On the left hand side, if you substitute in place of y 0, then left hand side value is 0. So 0 is equal to, in place of x, you have to substitute 0 value. So 6 minus 0 whole cube by 6, 4 minus 0 whole cube by 3, It says if you substitute 0 at this place, this term is 0, and 45 into 1 minus 0 whole cube by 3 plus C1 into 0 is 0 plus C2. So after substitution of first boundary condition, this value minus 48.33, 6 minus 0 whole cube by 6 plus 20 into 4 minus 0 whole cube by 3 plus 0 plus 45 into 1 minus 0 whole cube by 3 plus 0 plus C2. So after substitution of x value, we will get this equation. From this equation, we will get the C2 value. C2 value is 1298.21. This is a constant of integration, second integration constant from the first boundary condition. Then by substituting the second boundary condition, what is the second boundary condition? At x is equal to 6 meters, y is 0, deflection 0. So this boundary condition, substitute this boundary condition in the deflection equation. Simply in deflection equation, left hand side is 0. If again y is 0, left hand side 0. Then right hand side, in place of x, you should substitute 6 meters. So first term minus 48.33, 6 minus 6 whole cube by 6. Second term, if you substitute 4 minus 6 value at point in place of x, 4 minus 6 is negative value. So whenever the negative value get in the bracket term, we will not consider this term. This term can be neglected. And if you substitute in place of x 6 meters, 20 into 6 square. Plus 45 into 1 minus 6 is negative term. This total term can be neglected again. Plus C1 into x value 6, so 6 is C1. Plus C2 value is, already we calculated C2 value 1298.21. So 1298.21. Only we will consider this 20 into x square plus C1x plus C2. These three values should consider. The remaining values are not considered. This value is not considered. This value is not considered. Neglected value. If you substitute 6 in place of x, this term is 0. 6 minus 6. Therefore, 620 into 36 plus 6C1 plus C2. 20 into 36 plus 6C1 plus C2 value is 1298.21. So upon calculation of this equation, upon simplifying this equation, we will get the C1 value minus 336.36. These are the two integration constant after substitution of these two boundary conditions. So final slope and deflection equations are EI dy by dx is equal to, again I am writing slope equation in place of C1 minus 336.36. And again I am writing here deflection equation in place of C1, C2 values, we are writing minus 336.36x plus C2 value is 1298.21. Simply replace the C1, C2 with their values. Then we will get the slope and deflection equations, final slope and deflection equations. After getting the slope and deflection equations, we can find the slope deflection under the loads. Here in the problem, he asked that determine the deflection at the point C and D. You should find the deflection at point C, D. This is the vertical displacement at C. This is the vertical displacement at D. How much deflected the beam at point C and D. So if you want to find the deflection at point C, you should substitute in place of x, how much distance? It is 1 meter. If you substitute x in place of x 1 meter, we will get the deflection at point C in the deflection equation. If you substitute x value as 4 meters at point D, 4 meters, then we will get the deflection at point D. Okay. First time x is equal to 1 meter, second time x is equal to 4 meter, then we will get the deflection values. So deflection at point C means at x is equal to 1 meter. Substitute this 1 meter in deflection equation. Deflection equation is EIYC. I am writing in place of y simply YC. Why? Because we are substituting x plus 1. We are substituting in place of x 1 meter, then y becomes YC. EIYC equal to minus 48.336 minus 1 whole cube by 6 plus 20 into 4 minus 1 whole cube by 3 plus 20 into x square is there. 20 into 1 square is 120 plus 45 into 1 minus 1 whole cube by 3 minus C1. C1 into x is there. 336.36 into 1 plus 1298.21. So after calculating these total value on the right hand side, we will get the 154.97. It is all the constant values, 154.97. Therefore, YC is equal to 154.97 by EI. EI is the flexural rigidity which is given in the problem as 90,000. 90,000. So therefore, 154.97. This is the flexural rigidity of the beam is 90,000 kilonewton meters square is given in the problem. EI value, flexural rigidity means EI value. So after substitution of EI value in this equation 90,000, we will get 1.72 into 10 to the power minus 3 meters. The deflection comes in meters. After conversion to millimeters, simply 10 to the power minus 3 is cancelled. 1.72 mm. Downward deflection. How to say it is downward? We got positive value. YC is positive value. Then we can say that it is downward deflection. The upward deflection is negative. Downward deflection is positive. If you get this value as negative on the right hand side, then it is upward deflection. Okay. So deflection at point D. That means at x is equal to 4 meters. X is equal to 4 meters. So in the same deflection equation, substitute in place of x 4 meters. So EI YD is equal to, YD means deflection at point D. If you write that YD in place of y, you have to substitute 4 meters at x place in place of x. So EI YD equal to minus 48.33, 6 minus 4 whole cube by 6, plus 20 into 4 minus 4 whole cube by 3, plus 20 into x square is there. Here 20 into 1 square is 20 only. 20 into 4 square 16, 20 into 16. At this place, if you substitute 4 meters, 1 minus 4 is negative term. Therefore, this term can be neglected. Directly, I am writing this value. 336.36 into x is there. 336.36 into 4 plus 1298.21. So after calculating on the right hand side, we will get the 208.33 value. It is also positive. Therefore, deflection at point D is also downward deflection. So therefore, YD equal to 208.33 divided by EI flexural rigidity, that is 98,000. We will get 2.31 into 10 to the power minus 3 meters. If you convert into the millimeters, 2.31 mm downwards. So 2.3 mm downward deflection. The beam will deflect at point D is 2.3 mm distance, vertical displacement downwards. These are the deflection at point C and D. If you substitute in place of x, 1 meter once and second time 4 meters. Clear, students? This is the problem to calculate the deflections at point C and D. Let us look. These are the two homework problems. You have to try these problems after looking all the videos, deflection chapter. Then you can try these problems, two problems, example 14 and 15. Example 14 is simply supported with UVL. UVL is the maximum intensity is W load at its left support and 0 intensity at right support. Take the XX section somewhere else at the distance of X from the left support, and that at XX distance the height of the triangle is W into L minus X by L. By taking the similar triangles, we will get this height. Okay, after getting this height, I should write the bending moment equation at XX after finding the RARB. First of all, you have to find the reaction forces, then write the bending moment equation at XX. After writing the bending moment equation at XX, substitute in curvature equation and integrate 2 times, substitute the boundary conditions. What are the boundary conditions for this? At x is equal to 0, y 0. At x is equal to L, y 0. These are the two boundary conditions for this case. And by substituting two boundary conditions, we will get the C1, C2 values. And here in this problem, asked that determine the slope at supports of the beam as shown in figure. What is the slope at this point? What is the slope at this point? If you substitute in place of x 0 value, then we will get the slope at this point. If you substitute in place of x L in the slope equation, you will get the slope at point B. Okay. Try it. These are the answers. Theta A, that is the slope at point A, is WL cube by 48 EI. Slope at point B, theta B equal to minus 7 WL cube by 360 EI. These are the answers. Check your answers with these answers. And also take this example 5 as a homework. It is a overhanging beam which is supported at point B and C. B to C is the overhanging portion. An overhanging beam ABC loaded as shown figure. Find the slopes over each support. That is slope at A and slope at B, and deflection at the free end means at C. What is the deflection at point C? Take E value as 2 into 10 to the power of 5 newtons per mm square. I is 5 into 10 to the power of 8 mm power 4. First of all, convert this E into kilonewtons per meter square, I in meter power 4. Then multiply these two EI value, we will get the EI value in kilonewton meter square. After conversion of EI value, E and I, find the RA, RB values, and then take the x section between A and B at a distance of x from the left support, and find the bending moment equation, substituting curvature equation. After getting curvature equation, integrate 2 times. Then after integration 2 times, we will get the slope and deflection equations, including C1, C2 values. So by substituting the boundary conditions, what are the boundary conditions for this overhanging beam? At x is equal to 0, deflection is 0, y 0. And at x is equal to 6 meters, support is there at 6 meters. This is not the support, it is the load, 10 kilonewtons. This is the support. At x is equal to 6 meters, y 0. These are the 2 boundary conditions. After substituting 2 boundary conditions, we will get slope and deflection equations and find the slope at A and B, deflection at points. So if this beam will be deflected like this, if the load is acting at this point, the beam is deflected. How to deflect this beam? Like this. Beam deflected like this. So between A and B, the beam deflected upwards, and between B and C, the beam is deflected downwards. So deflection at point C is downward deflection. It is positive. You will get the positive deflection. And the slope at this point A is anti-clockwise slope. It is negative. And if you draw the tangent at point B, it is the clockwise slope. It is positive. So theta B is positive, theta A is negative, and YC is positive. Okay? Try it. Otherwise, I will tell you this problem, overhanging beam, in the next class. So this is the another problem, simply supported beam with couple. This is the deflected beam after deflection. The moment is acting at point C. We'll go for this problem. After calculating the slope and deflection at different points, we will get example 7 is there. It is also overhanging beam. In the next class, I will discuss this overhanging beam. Okay. Then this is the list of formulas which are derived up to now, maximum slope and maximum deflection formulas, but simply first some standard beams. After completing this, we'll go for another method, moment area method is there in the next class. So now I will explain this problem, example 6. A simply supported beam AB of 6 meters length. The beam is subjected to clockwise couple, 300 kilonewton meter. This is the clockwise couple. 300 kilonewton meter is the value at a distance of 4 meters from the left support. 4 meter distance lo oka couple 300 kilonewton meter clockwise couple act avutundanta. Total span is 6 meters, which is simply supported at ends A and B. I locate this point as C where the couple is acting. Okay. If E equal to 2 into 10 to the power of 5 megapascals and I equal to 2 into 10 to the power of 8 millimeter per 4. The Young's modulus for the given beam and a moment of inertia over the given section A is given. Then determine the deflection at a point where the couple is acting. Deflection at point where the couple is acting. ఎక్కడైతే couple act అవుతుందో ఆ point దగ్గర deflection ఎంత. Then second bit, the maximum deflection in the beam. ఎక్కడ maximum deflection అక్కడ అవుతుంది. These are the two bits we are going to find. So whenever we act, the couple is acting at points like this, the beam deflects like this. The upward deflection, and then towards the B, it is downward deflection like this. The beam twist, if it apply the couple at a certain point, the beam twist like this. Beam twist like this. If a beam twist, left hand side portion goes upwards and right hand portion goes downward deflection. Okay, I shown here the deflected beam like this. So here we are going to find the deflection at point C, that is upward deflection. It must be negative. It comes in negative. And maximum deflection, how much deflected, maximum deflection occurs in the beam, which is also upward direction, maximum deflection. A small deflection in the downwards. So let us look. E is the 2 into 10 to the power of 5 megapascals. Megapascals means newtons per mm square, or 10 to the power of 6 newtons per meter square. If you convert into kilonewtons per meter square, we will get 2 into 10 to the power of 8 kilonewtons meter square. Okay, 2 into 10 to the power of 5. I will explain that. 2 into 10 to the power of 5 megapascals means 10 to the power of 6 into 10 to the power of 6. Mega means 10 to the power of 6. Pascals means newtons per mm square. Okay, newtons per mm square. So if you want to get the kilonewtons in this 10 to the power of 6, subtract 10 to the power of 3, remaining 24 10 to the power of 3 multiplied by 10 to the power of 5, therefore 10 to the power of 8 we will get. 10 to the power of 8, 10 to the power of 3 newtons per meter square means kilonewtons. So kilonewtons per meter square. Like this, you have to convert E value into kilonewtons per meter square. 2 into 10 to the power of 8 kilonewtons per meter square. Why? Because why we converting the kilonewtons? The load or couple is there kilonewtons, kilonewton meter. That's why I'm converting kilonewton per meter square. Then I value is given is 2 into 10 to the power of 8 millimeter power 4. If you convert millimeter power 4 into meter power 4, we'll get multiplied. We must multiply it with 10 to the power of minus 12. So 2 into 10 to the power of minus 4 into 10 to the power of minus 12, then we will get the 2 into 10 to the power of minus 4 meter power 4. 2 into 10 to the power of 8 into 10 to the power of minus 12. So we'll get 2 into 10 to the power of minus 4 meter power 4. Clear, students? After getting the I and I value, multiply those two, we will get the flexural rigidity value as 4 into 10 to the power of 4 kilonewtons meter square. So after getting the EI value, you must find the reaction forces. You should find the reaction forces at point A and B. To find the reaction forces, take the sigma Fy equal to 0, equilibrium equation. So what are the loads acting on the beam? There is no load acting, vertical load acting on the beam. Therefore, RA plus RB upward forces, downward forces are 0. So RA plus RB equal to 0. This is not the force, it is couple is acting at the point C. It should not take it as load or force. So beam will act a vertical load and that is 0. RA plus RB equal to 0. Then take the moment at point A, another equilibrium equation, sigma MA equal to 0. If you take the moment at point A, RB into 6 meters distance, force into perpendicular distance is the moment. RB into 6 is the anti-clockwise movement is positive. So RB into 6. This is the clockwise movement acting at point C, 300 kilonewtons meter. It is clockwise movement kabatti minus తీసుకుంటాం, therefore minus 300. You simply substitute this 300. You should not multiply with the distance. Distance to multiply చేయదు, ఎందుకంటే it is not a force, it is already a couple or moment. So minus 300 is equal to 0. If the force is acting at point C, 300 kilonewtons, you should multiply the distance. But it is not a force, it is a couple. That's why I'm not multiplying any distance with this 300. So simply I'm writing 300, negative sign represents the clockwise. That is equal to 0. Then we will get the RB into 6 equal to 300. RB is equal to 300 by 6. It is 50. RB is equal to 50 kilonewtons. RB 50 అయినప్పుడు RA ఎంత వాల్యూ అవుతుంది? RB 50 అయితే the summation of these two must be 0. So RB 50 అయినప్పుడు RA must be minus 50. So RA is minus 50. Minus 50 means if you apply the couple at this point, the upward reaction force developed at the point B and the downward reaction forces developed at the point A. So if you force applying in this direction by applying the couple, the force applying on the beam in this direction and the force applying in this direction on the right hand side. If you force applying downward direction, upward reaction forces develop. If you apply the upward force on the left hand side between A and C, downward reaction forces will be developed. So minus represents downward deflection, downward reaction force. Okay, students. So after getting the RA, RB, consider XX section again. XX section at a distance of X from the left to support. So at XX distance, you have to find the bending moment again. Bending moment equation. What is the bending moment at XX? Right hand side forces are RB is there and one moment is there. Due to these two, bending moment will be developed at XX. So bending moment at XX, M equal to RB into this total distance X from X to B. So distance from X to B is total distance 6 meters. By subtracting X value from 6 minus X is the distance. So RB into 6 minus X, anti-clockwise direction positive, and 300 is there. It is clockwise minus 300. Simply you have to write minus 300. You should not multiply the distance again. So M equal to 50 into 6 minus X. 50 is the RB value. RB into 6 minus X or 50 into 6 minus X minus 300. It is a clockwise couple కాబట్టి minus తీసుకుంటాం. This is the bending moment equation at XX. Okay. Wherever you take the section, in this XX section, you should take the minus 300 only. 300 not distance. Okay, 300, you should not multiply the distance with this 300. Wherever we take the XX section or wherever you calculate the bending moment, simply you have to take the 300 as minus 300. Then from the curvature equation, EI d square y by dx is equal to minus M. This is the curvature equation. By substituting this M value in this equation, minus 50 into 6 minus X, minus plus 300. This is the curvature equation after substitution. So integrate this equation 2 times, then according to the Macaulay's method, we will get the slope equation and deflection equation. If you integrate this equation once, we will get the slope equation. If you integrate this equation twice, we will get the deflection equation. So integration of once, this equation EI dy by dx on the left side is equal to integration of 6 minus x minus 6 minus x whole square by 2. So minus plus 50 by 2 is 25, 25 6 minus x whole square. Plus 300 integration 300x plus C1 is the constant. Upon integration of second time, EIY we will get the on left hand side. 6 minus x whole square integration is minus 6 minus x whole cube by 3. Minus 6 minus x whole cube by 3. So minus again, it will comes in front of the expression. Minus 25 6 minus x whole cube by 3. Plus 300x integration 300x square by 2. 300 by 2 is 150 x square. Plus C1x plus C2 is the second integration constant. Okay, these are the two equations including C1, C2 values. These are the boundary conditions at x is equal to 0, y0, at x is equal to 6 meters, y0. These are the two boundary conditions for simply supported beam. At left support, deflection 0, at right support is also deflection 0. So after substitution of boundary conditions to our equation, from the first boundary condition, what is first boundary condition? X0, y0. If you substitute in this equation, deflection equation, y0 on left hand side, so for left hand side 0 value is equal to minus 25 by 3, 6 minus 0 whole cube. X value is 0, 6 minus 0 whole cube, plus 150 into 0 is 0, C1 into 0 is 0, plus C2. So minus 25, 6 minus 0 whole cube by 3 plus 0 plus 0 plus C2. So C2 value is 1800. Okay. From the second boundary condition, what is the second boundary condition? At x is equal to 6 meters, y0. Again, substitute the second boundary condition into deflection equation. So y0 got the left hand side 0, Substitute in place of x 6 meters. So 6 minus 6 whole cube by 3 means this expression is 0. 6 minus 6 is 0. So 150 into 6 square plus c1 into 6 plus c2. So this term is 0. 150 into 6 square is the 36 plus c1 into 6, that is 61 plus 1800. C2 value is 1800. So from this expression we will get the c1 value as minus 1200. This is the c1 value, first integration constant. After getting the c1, c2 values, substitute in the slope and deflection equations, then we'll get the final slope equation, final deflection equation. Okay, again I written these equations. ఈ రెండు ఈక్వేషన్స్ మళ్ళీ రాశాను by replacing c1 c2 values. c1 is minus 1200, c2 is 1800. Okay, these are the final slope and deflection equations after replacing the c1 c2 values with their values, c1 c2 constants with their values. Then what are the problem, what is the question asked in the problem? Determine the deflection at a point where the couple is acting. At C we have to find the deflection and maximum deflection. So C దగ్గర మనం deflection find చేయాలంటే x value ఎంత substitute చేయాలి? X becomes 4 meters at point C. Simply substitute x is equal to 4, then we will get the deflection at couple. Deflection at couple is equal to deflection at couple, that means that x is equal to 4 meters. So ఈ deflection equation లో x place లో 4 meters substitute చేస్తే we will get the deflection at point C. Therefore EIYC equal to minus 25, 6 minus 4 whole cube by 3 plus 150 into 4 square minus 1200 into 4 plus 1800. Then EIYC equal to, on the right hand side the value is minus 666.67. So minus sign వచ్చింది ఇక్కడ. Minus sign వచ్చింది అంటే deflection at point C is upward deflection and so beam upward deflect అవుతుంది అని. So YC equal to minus 666.67 by EI minus 666.67 divided by EI value is 4 into 10 to the power of 4 as given in the problem. Therefore we will get minus 16.66 into 10 to the power of minus 3 meters. So if you convert this meters into millimeters, then we will get the minus 16.66 mm. This negative sign represents upward deflection. Upward deflection is taken as negative, downward deflection is taken as positive. Okay students, so deflection at point C is minus 16.66 millimeters, that is 16.66 millimeters upward direction. Then maximum deflection he asked. How to get the maximum deflection? Where the deflection is maximum, ఎక్కడైతే మాక్సిమం డిఫ్లెక్షన్ అక్కడ అవుతుందో అక్కడ మనం టాంజెంట్ డ్రా చేస్తే హారిజాంటల్ గా వస్తుంది. ఫర్ ఎగ్జాంపుల్ ఇక్కడ మాక్సిమం డిఫ్లెక్షన్ అనుకోండి, ఇక్కడ మనం టాంజెంట్ డ్రా చేస్తే ఇట్ మస్ట్ బి హారిజాంటల్. ఇక్కడ మనం టాంజెంట్ డ్రా చేసాం అనుకోండి హారిజాంటల్ గా వస్తుంది, అంటే స్లోప్ 0 అని. at that point wherever the maximum deflection occurs there the slope is 0. అంటే స్లోప్ 0 పెట్టుకుంటే మనం dy by dx 0 అయిన చోట maximum deflection occur అవుతుంది. అదే ఇక్కడ నేను ప్లేస్ చేశాను. The maximum deflection in the beam is, the maximum deflection occurs in the beam at a point where the slope is 0. Slope is 0 అంటే మనం స్లోప్ ఈక్వేషన్ తీసుకుంటాం. This is the slope equation. స్లోప్ అంటే dy by dx is 0 పెట్టండి. సో ఈ లెఫ్ట్ హ్యాండ్ సైడ్ 0 అవుతుంది. ఈ ఈక్వేషన్ లో లెఫ్ట్ హ్యాండ్ సైడ్ 0 పెడితే we will get the x value. So 0 equal to 25 into 6 minus x whole square plus 300x minus 1200. So 0 equal to 25 into 6 minus x whole square plus 300x minus 1200. So after elaborating 25 into a minus b whole square form lo undi, 6 square is 36 plus x square minus 2ab, 2 into 6 into x minus 12x plus 300x minus 1200. 25x square, 25 into 12 minus 300x, 25 into 36 plus 900 plus 300x minus 1200. So 300x cancel. 25x square plus 900 minus 1200 is that minus 300 is equal to 0. So 25x square equal to 300. X is equal to 3.46 meters. అంటే ఏంటంటే ఈ x అనేది 3.46 మీటర్ డిస్టెన్స్ లో స్లోప్ 0 అవుతుంది, డిఫ్లెక్షన్ మాక్సిమం అవుతుంది. ఎక్కడ నుండి 3.46? ఫ్రమ్ లెఫ్ట్ హ్యాండ్ సైడ్, ఫ్రమ్ లెఫ్ట్ సపోర్ట్. మనం ఎక్కడ నుండి తీసుకున్న x లెఫ్ట్ సపోర్ట్ ఉంది. సో x ఎప్పుడైతే 3.46 meters అవుతుందో, అంటే ఇది 4 meters, up to this 4 meters, అంటే బిఫోర్ C point ఓన్లీ ద స్లోప్ 0 అవుతుంది. ఎక్కడైతే స్లోప్ 0 అవుతుందో అక్కడ మాక్సిమం డిఫ్లెక్షన్ అక్కడ అవుతుంది బీమ్. సో x is equal to 3.46 meters. సో డిఫ్లెక్షన్ ఈక్వేషన్ లో x ప్లేస్ లో 3.46 meters సబ్స్టిట్యూట్ చేస్తే we will get the maximum deflection. Therefore the deflection is maximum at 3.46 meters from the left support. సో డిఫ్లెక్షన్ ఈక్వేషన్ తీసుకొని x ప్లేస్ లో 3.46 meters సబ్స్టిట్యూట్ చేసుకుంటూ వెళ్ళిపోతే మనకి y maximum వచ్చేస్తుంది, maximum deflection. Okay, EI y max is equal to minus 25, 6 minus 3.46 whole cube by 3 plus 150 into 3.46 whole square minus 1200 into 3.46 plus 1800. This is the deflection equation. X place lo 3.46 substitute chesam ante. So EI y max is equal to, upon calculation of this value, we will get minus 692.81. Again minus sign is came. So this negative sign represents maximum deflection is also in upward direction. So y max is equal to minus 692.81 divided by EI. Minus 692.81 divided by EI value is 4 into 10 to the power of 4, which is given in the problem. Then we will get the minus 17.32 into 10 to the power of minus 3 meters. Or y max is equal to minus 17.32 mm. Minus sign represents upward deflection. So ఈ maximum deflection కూడా C దగ్గర upward deflection, maximum deflection కూడా upward deflection జరుగుతుంది. So beam bends like this. If you calculate somewhere in between B and C here, you will get the positive deflection. ఇక్కడ calculate చేయగలిగితే మనం calculate చేస్తే positive deflection వస్తుంది. For example, this 4 meters is 2 meters, 6 meters. If you find the 5 meters in the deflection equation, then we will get the positive deflection. But in problem, these two are asked. Deflection at point C and maximum deflection. Maximum deflection find cheyalante some calculations are more. So first of all, slope is 0, slope 0 chesukovali. Slope 0 chesukuna tarvata vachina value x value vastundi, where the deflection is maximum. By substituting that x value into deflection equation, we will get the maximum deflection at that point. Like this, you have to find the deflection at particular point C and deflection, maximum deflection. Okay, this is a problem which is asked at 2 points. So let us close this class, dear students. Okay, bye. In the next class I will explain another problems by using Macaulay's method, and after that I will explain the moment area method. Another method, a simple method is there, moment area method. That method is useful only for the simple loads are acting, the single loads are acting on the beam. Okay, bye students, have a nice day.